The moon, our celestial neighbor.
Obviously, when I'm walking around the city and I look up, I see my work, and I can see it very clearly.
Mysterious, magical.
I get out from the building, look, the moon. And it was kind of like separation in my soul.
We have a deep personal connection to this light that dominates the night sky.
Despite all the scientific work that I did, I love it.
The ultimate challenge, to explore space, to visit our nearest neighbor.
It's a whole nother world, just 3 days away.
Yet it seems distant, remote.
If you're gonna go to Mars, you need to go back to the moon first.
If we're going to travel further into space, we'll still need to start our journey here. Nearly half a century has passed since we last walked on the moon. Is it really cold and barren? Are there any natural resources? Could there even be water? So near, yet so far away. When we did land on the moon, there was no internet. Microprocessors were primitive, and computers too heavy to move.
You're coming down the ladder right now and on the surface. Okay.
In the almost 50 years since the last Apollo mission, the moon has been studied in detail using data collected by astronauts, remote-controlled robots, and a fleet of space probes. Now we know that the moon is being bombarded by meteorites, that its core, like Earth's, is hot and partly molten, and that it was shaped by volcanoes. Its soil can generate air to breathe, and its caves could provide shelter for space travelers. Our story begins at the end of the 1950s. The journey to the moon is long, hard, and expensive. Disaster strikes both America and the Soviet Union. Probes melt and rockets explode. And neither superpower could even target the moon accurately.
These were the first rockets that were launched, and the calculations, a lot of things were not understood very well. You know, velocity and the interactions of things, and how the effects of Earth gravity, and you know, just so many different things.
If your velocity will be a little bit smaller or a little bit larger, then you miss. So it is many such things, and engineers learned gradually.
February 1959. Communist revolutionary Fidel Castro assumes power in Cuba. In August, Hawaii becomes the 50th state of the United States of America. And America and the Soviet Union begin their race to the moon. 10 failures later, the Soviet Union wins the opening heat. Luna 2 is the first man-made object to land on another world. September 1959. Halfway to the moon, the space probe emits a cloud of sodium gas that can even be seen from Earth. The Soviet Union is telling itself and the whole world that Luna 2 is on the correct course. A day later, after 34 hours of flight, the probe reaches its target. Now traveling at a speed of 12,000 kilometers an hour, Luna 2 slams into the surface of the Marsh of Decay, east of the Sea of Serenity. A resounding success for the Soviet Union, and the world's attention turns to Moscow.
So it was science and propaganda. And propaganda was very important.
Before it crashes, Luna 2 transmits crucial information. Unlike Earth, the Moon has no magnetic field, which means there's no protection from deadly solar radiation. Human visitors to the Moon will need to take this into account. For more than 300 years, all the information we had about the Moon came from telescopes. They showed us that on the surface there were higher elevations with lots of craters and lower elevations with very few craters that became known as the lunar maria, or seas. These are formed of geological structures that we thought might be solidified lava, and now we can be sure. They are ancient lava fields. The Moon was once volcanic. We assumed this lava dated from the early formation of the Moon, until a few years ago when the Science Operations Center of the Lunar Reconnaissance Orbiter at Arizona State University received photos from the probe's camera, which questioned whether this was true. The probe identified 70 different lava structures on the Earth-facing side of the Moon that seemed much more recent. Could there be volcanoes on the Moon about to erupt?
Out of Apollo era, it was thought that all the volcanism shut off on the Moon maybe 1.5 billion years ago. But these have very few craters on them. They look very, very young. They might only be 10 million years old, and that sounds old, right? But in geologically, compared to 1.5 billion years, that's very young. So if we're right about that, then I would say it's probable that there will be volcanic eruptions in the future on the Moon. But let's go to the Moon, let's get a sample, let's find out how old these things really are, because what I'm saying right now is just sheer speculation.
And the Lunar Reconnaissance Orbiter has found another clue, suggesting that the Moon has a hot, molten core. More than 3,000 cracks, where the plates of the Moon's crust have collided or drifted over each other. These fault lines can be 10 kilometers long, and some are dozens of meters deep. They're still expanding, and there's only one explanation. The Moon is shrinking. The core of the Moon is molten, a solid 500-kilometer thick sphere of iron, surrounded by a glowing sea of sulfurous magma. The core is cooling, and the Moon is contracting. Its diameter has decreased by 100 meters in the last 800 million years. But how could we possibly know this?
Most of the evidence for this comes from the lunar laser ranging data, which is when we shoot a laser at the Moon to the lunar laser retroreflectors that were placed there by Apollo, and we measure the time that it takes for the reflected pulse to come back. And by measuring how the Moon kind of wobbles in its rotation as it goes around the Earth, we're able to determine that there's something kind of squishy in the interior. And that squishiness is due to the fact that the core of the Moon is today molten.
These laser measurements reveal another surprise. The Moon is slowly pulling away from the Earth at a rate of around 4 centimeters a year. But there's no cause for concern. At this speed, the Earth will have been consumed by the dying, bloated sun long before the Moon has left our orbit, in 7 billion years or so. In 1959, these ideas are yet to be understood. The Soviet probe Luna 3 takes photographs of the mysterious dark side of the Moon and transmits them to Earth. Although the images are of poor quality, they do reveal the rear side of the moon has almost no seas or areas of lower elevation. These dark regions, huge areas of solidified lava, only exist on the Earth side of the moon.
And the question is why? This is a question which still hasn't been resolved, and it's a very simple observation that anyone can make.
Is the moon's crust thicker on the other side? Did this stop the lava from breaking the surface? Could it be related to Earth's gravity? This near-perfect image of the rear side of the moon was produced 56 years after Luna 3's first exploration. In the early 1960s, the Soviets and Americans fire one probe after another into the moon. America's Ranger probes deliver better and better photos. Ranger 9 even broadcasts its final impact directly into American television sets. This is all happening at the same time the Beatles are setting out on their world tour. And America is dealing with the refugee crisis caused by the Vietnam War. But in 1966, the Soviet Union takes another historic step forward. On the 3rd of February 1966, the Lunar 9 probe becomes the first man-made object to set down gently on the surface of the moon. To do this, and prevent a crash, the Soviets have invented a simple, elegant solution. When Lunar 9 touches the moon, the landing capsule is ejected and bounces across the surface, protected by two large airbags. It eventually comes to rest in the Ocean of Storms, the largest of the lunar maria, and frees itself from the airbags. The probe opens like a flower, helping to stabilize it. And then the antennae emerge, along with a camera. The probe only survives 3 days, but it's enough to transmit the first ever panoramic photos of the moon's surface back to Earth. A technical and political sensation, also providing information about lunar dust, crucial to any plans for a manned moon landing.
Some people felt that the soil was so fluffy that if the astronauts landed a lunar module there, a big lunar module, that they'd sink right out of sight.
Because several years before that time, American novelist Arthur Clarke wrote beautiful novel about the moon covered with layer of dust. And in his novel, expedition landed and they started to sink in that dust.
And that caused a lot of consternation among the engineers, as you might imagine, because, Houston, Tranquility Base, bloop, and you're gone. That wouldn't have been very good at all.
And what we see on panoramas, it is not dust. It is, of course, dust with some pieces of rock. It's not like Clarke said. So it was some, I would say, fundamental knowledge what is lunar soil, and it was practical. Yes, we can land on it.
1969, and the Vietnam War is coming to an end. America has had enough and starts withdrawing troops. Far from the conflict, the Americans take the lead in the space race. 10 years after the race began, on the 20th of July 1969, a human being finally sets foot on the moon's surface. After a 3-day journey, American astronaut Neil Armstrong steps onto the moon as part of the legendary Apollo program. And the Soviets had given up.
Drift into the right, level. Down a half. 30 seconds. Forward. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed.
I think Apollo gave 2 gifts to humanity. One of them was opening our eyes to the solar system. Of course, everybody knows planets, but the fact that we had walked on the moon really made people think beyond the Earth. And that's not trivial at all because, we're just a tiny little speck on the Earth in the solar system, let alone in the cosmos. And so that began to make people really think beyond themselves, basically. And the second part was, of course, seeing ourselves from the moon. And that's the beautiful picture of the Earth as it rises above the moon that was obtained on Apollo 8. Just unbelievable. That changed everybody's thinking.
During the first tentative steps onto the moon's surface, the lunar dust is once more an issue. It's extremely fine and gets into everything.
Pretty hard, isn't it? That boulder's gonna roll.
With no wind or water to weather the particles, they have sharp, jagged edges, and the dust sticks to spacesuits, even finding its way into the astronauts' lungs.
The soil was a question, okay? So the question was much more, what would it do to the rings that connect parts of the spacesuit? For example, imagine a situation in which you couldn't get out of the lunar module because you couldn't get the ring turned tight enough because there was dust in there. But in terms of breathing it or the health issues, those weren't major concerns.
And there was another puzzle, still not solved. Lunar dust has a distinctive smell. Where does that come from?
The astronauts have told me that when they get back in the lunar module after a period of extravehicular activity, that there's a smell that smells like gunpowder. And they couldn't figure that out. It turns out that's the soil, and nobody's really sure exactly why that smell, but that's when they get in with their suits dirty and the samples and things like that. It smells like gunpowder. It would scare the hell out of me personally, but...
I'll verify him in a minute, okay?
Once the dust has been in contact with air, the smell eventually dissipates.
And it does move. Hallelujah.
The astronauts are getting more experienced. But in 1972, after just 6 landings in 3 years, the Apollo program is brought to a close.
What do you think, Jack?
Exploration is really interesting. It does not proceed in a very linear fashion. I mean, if you think about the time between the discovery of America and further voyages and settlements and things like that, it's hundreds of years. And so it does not surprise me, although it disappoints me, that after Apollo 17, that we didn't quickly continue our exploration of the moon with other means, with humans.
I think there's kind of a myth out there, and it's propagated by the press and even the science community, that somehow after Apollo 11, that people weren't interested in the moon. Because a lot of people don't really follow the space program in detail, but they kept asking the question over and over again, why aren't we on the moon? Why can't we go to the moon? And I had to answer to them, well, because we choose not to go to the moon. It's not that we can't, but we just don't.
While the Americans are putting men on the moon and bringing them back safely, the Soviets are trying something different: robotic probes. Success comes just a year after Neil Armstrong's historic mission. In 1970, they're the first to land a remote-controlled probe on the moon. Luna 16 collects rock samples and returns them to Earth. The Soviet press is triumphant. Only 105 grams of lunar soil are brought back, but it's enough to rescue the reputation of the Soviet space program. And just 2 months later, the Soviets score another point. They land an unmanned rover vehicle on the moon. Lunar Cod 1 is the first remote-controlled robot to roam over the surface of another world. For nearly a year, it explores and investigates the moon's surface and sends more than 20,000 photos back to Earth. The robot travels 10 kilometers across the rough surface. A very different achievement from the American landings, but just as unique. Alexander Basilevsky was the supervisory geologist during the mission.
It was a long session all the night. Lunokhod was moving, and I was sitting in the room where crew was. I was like one extra member of the crew, geologist. And then early in the morning, session was over, I get out from the building, look, the moon. And it was kind of like separation in my soul. I was looking very closely on that landscape. So I was almost there, and then it is so difficult, so far.
In 1976, the successful Luna 24 mission marks the end of the Soviet space program. Just 4 years after the Americans abandoned their lunar exploration. Luna 24 is the last probe to bring samples of the moon back to Earth. "20 years have passed since the very first probe crash-landed onto the moon's surface.
It was political decision, and also in science, in space science, in Russian space science, there were people who studied the moon, and there were people who studied Mars, and they were complaining that all resources go to moon, and so on. So, but then it was in '76 was over.
When humans set foot on the moon 50 years ago, they were stepping onto unexplored territory. But things are very different now. The geologist Jim Head trained astronauts and had to identify safe areas where they could land.
So when I started in the Apollo program, we didn't know whether the moon was cold or hot. We did not know whether the dark areas on the moon were lava flows or dust. We did not know the age of the surface. Some people thought it was hundreds of thousands to a few millions of years. Other people thought it was billions of years. We didn't have a clue. We didn't know anything about the origin of the major features. The Apollo 15 sinuous rill that Dave Scott and Jim Irwin landed near, some people thought that was due to water. To water, okay? Not a silly idea at the time. We didn't know. We didn't know where the moon came from. We didn't know. We didn't have a clue.
During their expeditions, the astronauts make discoveries that only become significant later. But they do show the moon isn't just dull, gray, and featureless. It has color.
So basically you see various shades of gray on the moon, you know, from white to basically dark. But in very few locations, like the Apollo 17 landing site, Jack Schmitt discovered some orange glass beads.
Oh, hey! There is orange soil. Well, don't move it till I see it. It's all over. Orange! Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange.
The astronauts are fascinated by solidified drops of magma, volcanic glass. And these glass spheres are found in other locations on the surface.
So those are really sort of the exceptions. Otherwise, the moon is fairly colorless and just has various shades of grays.
35 years later, the geochemist Alberto Sal causes a sensation. He discovers water molecules inside the glass spheres. Although they're few and far between, this reveals that lunar rock contains water. Final proof of something long suspected.
Interesting that first publication that the moon samples have some traces of water was Russian. It was in my institute, in my colleague, she published it in geochemistry, geochemia, but nobody believed. And everybody said that it's some contamination on Earth. She probably was correct.
But Alberto could actually show that the water content increases in the interior of these little glass beads. And so that's a really good piece of evidence that the water comes from the moon. And so in the 70s, we could not have done these analyses because the capabilities were still simply not there.
Water on the moon. Did this mean that astronauts could be supplied with drinking water, hydrogen fuel, and oxygen?
So that's definitely a really cool discovery.
Lunar rock is suddenly seen in a different light. At the Solar Energy Research Center, Plataforma Solar de Almería, in southern Spain, aerospace engineer Thorsten Denk has invented a way of using sunlight to extract oxygen from lunar rock. Denk uses a titanium iron oxide mineral found on both Earth and on the moon. It's heated to a temperature of 900 degrees Celsius using the strong Spanish sun. The sun's rays are focused into a reactor chamber over several hours. The heat melts the ore, creating magma, which starts to release oxygen. Hydrogen is introduced, binding with oxygen to make water. The thermal solar reactor is designed to work on the moon and, in principle, to be transported there. The water is collected and the waste materials are removed. Electrolysis is then used to split the water, releasing oxygen for breathing and hydrogen to be used again. Thorsten Denk hopes to produce 3/4 of a liter of water per hour, using energy from the sun. Ideally, the reactor would be positioned between the Sea of Serenity and the Sea of Tranquility, where Apollo 17 landed in 1972. The area is thought to have the highest concentration of titanium iron oxide on the moon. Mining an area the size of a football field should provide ore to fuel the reactor for several years, creating enough oxygen to support 8 astronauts. The dream of producing oxygen and water on the moon isn't new. It's been around for many years. In 1994, the probe Clementine sends back photos showing that this might one day be possible. Its cameras provide data for the first comprehensive map and globe of the moon. During its mission, Clementine discovers a massive impact crater on the far side of the moon, the South Pole Aitken Basin, the largest in our solar system. Here, the probe finds tantalizing hints of water ice that might have been deposited by meteorites. But reaching the basin looks impossible. The craters at the poles are among the darkest and coldest places known to humans. But maybe it could still be done with some ingenious technology.
It is like in polar areas of Earth. You have in summer, you have very low sun, it goes, and in some places there is some mountains where almost always is sun.
So you might be able to power your operations with a combination of solar power from these highly illuminated peaks on the rims of the craters, and a combination of that and nuclear power to get down inside and mine. I don't think you would really need to send people down there for that. It's kind of a robotic type thing you would want to do.
I would go to this dark crater, but I may send lunokhod there and grab what I wish. And meanwhile, I will enjoy the sun.
Robots will have to find the ice at the lunar poles. And they might replace humans in much of space exploration, but never completely. If astronauts hadn't used their intuition, we still wouldn't know when and how the moon came into being.
I think humans on the surface are really a huge asset. Dave Scott, John Young, Jack Schmidt, they understood the geology. They could react, and they could react really quickly. They saw all those rocks are similar, but this is different, so I have to sample this, and they could just grab it. Classical example is the seatbelt rock at Apollo 15, where Dave Scott basically hopped off the rover and grabbed the rock, and the Genesis rock.
The 1st of August, 1971, Apollo 15 commander Dave Scott finds a white stone the size of a fist, the famous Genesis rock.
Guess what we just found? I think we found what we came for. Crystal and rock, huh? Yes, sir. You better believe it.
The rock is no less than a piece of material that solidified during the first stages of the moon's creation. More than 4 billion years old, it gives a vital clue about the age of the moon. This unique piece of rock is given its very appropriate name, the Genesis rock. 16 months after the rock is found, humans leave the moon behind. We've never been back. The last humans to walk on the moon are Apollo 17 commander Gene Cernan and geologist Jack Schmidt. In December 1972, they spend 3 days on the surface and return with the largest collection of rock samples collected so far. Over the 6 American manned missions, around 400 kilograms of geological samples are collected and brought back to Earth. After this farewell to the moon in 1972, there's still more than enough rock for scientists to examine. But the moon rock is kept locked away, and only tiny amounts are provided for research.
From those samples, we learned so much, despite the fact what people usually say about Apollo, that it was just a race to the moon and scientifically was not successful. That's wrong, completely wrong.
Studying the lunar rock, it's soon clear that its chemical makeup has a lot in common with that of the Earth, as if the two were somehow related. So where did the moon come from? Since 1975, scientists have assumed that in the early days of our solar system, a mighty protoplanet collided slowly with the young Earth.
The current hypothesis for how the Earth-Moon system formed is that you had an object roughly the size of the Earth that was hit by an object roughly the size of Mars. Now, there's many variants on this story, and it's actually a field that's being actively debated as to how to do this, but that's the general idea.
More recently, Israeli researchers calculated that a number of smaller cosmic rocks collided with Earth, rather than one large planet, and this happened over an extended period. Just 20 of these collisions could have released enough material into orbit that would eventually coalesce to form the Moon. But why could such understanding be any use to us?
So to me, all these questions about planetary science and what's the utility and so on, it always comes down to the fact that by better understanding what's going on with other planets in our solar system or with the Moon, it tells us something about the Earth.
The Moon was once 10 times closer to the Earth than it is now. This had a dramatic effect on our planet. The tidal force of the Moon was 1,000 times stronger. Earth's crust rose and sank with the rhythm of the Moon. High and low tides were more powerful than we can imagine. In the newly formed oceans, flood waves could reach 1,000 meters high. After 1976, the Moon was explored by remote technology, robotic probes. The Lunar Reconnaissance Orbiter has circled the Moon since 2009, sending back photos that are clearer and sharper than any from earlier probes. The newest discovery is that meteorites bombard the Moon far more often than we'd previously estimated.
And now we're taking pictures today, where we took pictures yesterday, and in 70%, we find changes to the surface. And right now, I kind of lose track, but the last count, we found over 400 new impact craters. And it was just so spectacular to see that. And we have the before image and the after image, and then when you blink them, it's like, oh my gosh.
The surface of the Moon is being reshaped 100 times faster than we once thought. Most of the changes are caused by small meteorites, but some still trigger massive tremors.
If you have a large impact somewhere close by, you would definitely feel the Moon ringing like a bell.
A large meteorite hitting the surface makes the Moon vibrate for hours. But impacts aren't the only reason the Moon is quaking, as the Apollo missions revealed. Astronauts position seismometers on the surface to measure seismic activity and send the results back to Earth, where observation centers record continuous, gentle quakes.
Most moonquakes that were registered by the Apollo seismometers have a magnitude of 2 or 3, and so that's hardly perceptible if you would have a magnitude 2 or 3 earthquake here on Earth, you know, so I'm not sure that you could actually feel it.
But this was still an incredible discovery. The Moon quakes from within. In the same way the Moon's gravity generates tides on Earth, our planet's gravity creates movements below the Moon's outer crust, which are measured by the seismometers. Other quakes occur at the end of the 2-week-long freezing lunar night. When sunlight hits the cold rock, the temperatures rise suddenly from minus 100 degrees Celsius to plus 100 degrees. The Moon's crust expands, generating moonquakes. Since 1958, More than 100 missions to the moon have tried to unlock its secrets. Some discoveries confirmed existing theories, but others opened up whole new mysteries. Scientists are now trying to understand what causes phenomena that could come straight out of a science fiction film. Mysterious flashes of light have puzzled researchers for centuries. At the University of Würzburg in Germany, engineers are developing and testing a system to track the moon and automatically record video when an unknown flash appears. Hakan Kayal and his team hope to capture the fleeting light and understand its origin, and finally disprove the different wild theories it's generated, including numerous ghost stories. A few witnesses claim the lights come in different colors. Sometimes they're gone in seconds, sometimes they last longer. Are they meteorite impacts, electrostatic discharges, or glowing gases? There are several possible explanations, some of them rather mundane.
If you're looking through a telescope for several hours on end, you become tired and you start seeing things. So I think a lot of this is just they're tricks that our mind is playing on our eyes.
But maybe not. The German researchers are trying to establish scientific facts that could explain these mysterious effects. Of the strange phenomena that create the greatest speculation, most are somehow related to light. Unusual twinkles and reflections feed the imagination. And among these, an eerie glow on the moon's perimeter, an apparition also seen by the Apollo astronauts. But even this has been explained. The phenomenon is caused by lunar dust. It floats, scattering the sunlight, the same effect as Earth's twilight, which is produced by light being diffused by our atmosphere. But the moon doesn't have an atmosphere. In 2005, scientists realized the dust floated because the particles were being charged by solar wind. Nearly all the mysteries of the moon have now been explained by science. But a few still remain. The ocean of storms is at the center of a mystery that can even be seen from Earth. Over hundreds of kilometers, lunar swirls circle like milk stirred into a fresh cup of coffee. Nothing like this has ever been seen anywhere else in the solar system. One is clearly visible and has been named Rayner Gamma. Since 2010, scientists have been convinced this lunar swirl is caused by magnetism. Although the moon doesn't have a real magnetic field, there are places where sections of the crust are magnetized. These magnetic fields affect the solar wind. They create shields that protect the lunar dust and prevent weathering. Away from the magnetic fields, dust gets darker over millions of years. The moon's strongest magnetic anomaly is found in the vicinity of the Gerasimovich crater. It shields an area the size of Portugal from the deadly radiation effects of the solar wind. This would be the ideal place to establish a manned lunar base. Or that's what everyone thought, until Japanese probe Selene, an American lunar reconnaissance orbiter, discovered a truly sensational massive hole in the moon's floor.
We've tilted the spacecraft over and we've looked as far as we can with the sun behind us, and we can see that the sides go down and then they go like that. It's about, say, 100 meters in diameter, and it goes straight down 100 meters. So the thought is that maybe that's what's called the skylight, which are common on the Earth. When basaltic volcanoes erupt, they form a plumbing system, and that's how the magma can get out of the vent and get distributed far from the vent. They can stay open for, many days, weeks, months, and sometimes get reactivated. I've actually seen some of these skylights before with active lava flowing through them. They're really very spectacular.
The reason why we really got excited about those skylights is that they would make very nice habitats for astronauts, because once you're underneath the surface in one of those lava tubes, okay, you are protected from the cosmic rays, you are protected from huge temperature excursions, so you're protected from micrometeorite bombardment, so that makes all really good habitats, basically.
So if you could get easy access to an underground tunnel, it would save you a lot of money.
I'm quite skeptical. I was in such caves, in lava tubes in Kamchatka. And when you are in that tube, this is moonquake, and it can...
But the fact that they're still there means they last a long time. Because if they don't last a long time, they wouldn't be there anymore.
I would be afraid to go into lava tube. It's too much unknown for me.
After 1972, no other country would take on the costs and risks of manned moon flights. In 1976, the last of the lunar probes brought a small amount of moon rock back to Earth. Then, for a long time, neither humans nor robots landed on the moon. The Soviets had given up, and once the last Apollo mission had returned, the Americans stopped investing in further landings. America had created 12 heroes, 12 men who had set foot on the moon. No lives had been lost, and it seemed best not to tempt fate. From then on, America dedicated its space program to space stations that would circle the Earth, and they set their sights on Mars. The moon was left to the Chinese. In 2013, China returns to the moon, the first visit in 37 years. A rover with ground-penetrating radar explores the moon's geological makeup and sends high-resolution photos back to Earth. Meanwhile, Americans design a spaceship to make the journey to the moon, or beyond, to Mars. Orion has room for 6 astronauts and is still in the testing phase, but the project is running 6 to 8 years behind schedule. Orion will be able to reach the moon, but the astronauts won't be able to land. The Constellation project to develop a landing craft was cancelled in 2010. Impossible dreams are still a driving force behind space exploration, and Russians, Americans, and Europeans are working on establishing a human outpost somewhere in space. The Europeans are committed to the idea of a lunar village constructed from materials found on the moon. The Russians and Americans, on the other hand, hope to create a space station to circle the moon, much like the International Space Station that still orbits the Earth after many years. Will the moon's natural resources and the possible economic benefits speed up these projects?
Some people might look at it as a large piece of rock to be mined and to send these materials back to the Earth. But in terms of whether we will actually find resources on the moon that are useful for humans on the Earth, my personal opinion is no. My personal opinion is that we will find resources on the moon that will be useful for people living on the moon.
In my opinion, it would definitely make sense to go to the moon, test the equipment of landing, of surviving on a hostile surface before I go, for example, to Mars. You know, at the moon I'm in 3 or 4 days, and if something goes wrong, I'll be back fairly quickly. On Mars I fly half a year, I have to spend a year at Mars, and then I fly half a year back.
It could be convenient base, you come to the moon, you repair something, and then you fly to Mars.
If we don't get back to the moon, there's many, many science questions that we just can't answer. But also, we're never going to get off planet Earth in a sustained way if we don't go back to the moon first. There's no doubt in my mind that's where we have to do it.
Well, I think human exploration of the moon is inevitable. And one of the main reasons for that is what the Apollo 16 commander John Young is fond of saying, which is that single planet species don't survive. And that simply means that if we don't get off the Earth, humans won't survive. We're the first species, I think, that can take our fate in our own hands and recognize the inevitability of extinction. 99% of the species that ever lived on this planet are extinct.
For thousands of years, we've been fascinated by the moon. Perhaps it's now time to unlock its full potential.
I think the moon has many purposes. It'll be a little bit for scientists, it'll be a little bit for explorers, it'll be a little bit for everyone.
And tourists, if not too many of them.